So today we are still in Unit 5. We are on Day 5, our last lesson for this unit, Geometric Mean. Unit 5, Day 5, Geometric Mean. And remember from middle school, elementary school, I don't know when we learned how to average. Probably middle school is where we learned the term mean. You have mean, median, mode. Mean is the average of numbers, right? When we're talking about geometric mean, it's a geometric average. So we don't do it the same as in arithmetic mean, where we're just adding how many we have and dividing by how many we have. It's done a little bit differently for geometric mean. For the geometric mean, we say G, the geometric mean between two numbers, A and B, those are my two numbers, can be found by setting up this little tiny proportion. Let me zoom in so you can see it. So the geometric mean between A and B. So we put A and B on the opposite corners of a proportion, and then the geometric mean goes in the remaining spaces. Okay? So if you want to solve this for G, what you would have to do is cross multiply, right? And you would do G times G and get G squared equals, and then you would do A times B. Do you remember how to unsquare something? Yeah, anytime you need to unsquare something, you square root it. Because squares and square roots, anytime you have a square and a square root together, they undo each other. So it doesn't matter if I square a square root or if I square root a square. I know that sounds weird. If I square a square root or if I square root a square, I end up with just whatever was under there. So here I've got a square root and a square, so I end up with just G. And when you take the square root, we end up with positive and negative, but in geometry we generally stick to just the positive result. So it's just the square root of whatever that product was to find your geometric mean. Okay? So let's look at an example. Number 1. Find the geometric mean between 5 and 45. So your geometric mean goes here and here. And then the 5 and 45 go in the other spaces. And sometimes you'll hear it referred to as your means and your extremes. You have your geometric means on one diagonal and the extremes of the ends on the other diagonal. Means and extremes. Okay? Not important vocab, just kind of for your information. So we cross multiply and we're going to get G times G, which is G squared. And then 5 times 45. Only 3 people picked up calculators. No, only 2 people picked up calculators today. Now just FYI, when you take your test, you can't use your phone as your calculator, right? So you need to make sure you know how to square root on the Inspire graphing calculator, right? That's going to be important. So 5 times 45 is 225. And then to unsquare it, I square root. And G equals the square root of 225 is just 15. So G equals 15. Your geometric mean is 15. Number 2, my second example is a little bit different because on number 2, it tells me 16 is the geometric mean. So that means when I set up my proportion, that 16 is going to go in where I had the G. So in both of those places. And then between 8 and which number, so 8 and some other number. So you have to pay attention. Are you looking for the geometric mean like number 1, or did they give you the geometric mean like this one? So I cross multiply 8 times x and 16 squared, or 16 times 16, which gives me 256. How do I get rid of the 8? Divide. Division property of equality. And x equals 256 divided by 8, which is 32. how do we use geometric mean in geometry? We use it with right triangles. We have two theorems that we use it for. We have the right triangle altitude theorem and the right triangle leg theorem. Okay? So my right triangle altitude theorem says the altitude from the right angle in a right triangle is the geometric mean of the divided parts of the hypotenuse. Okay, so there's a lot of words there. Let's break it down and talk about what it's talking about. So first, the altitude from the right angle in a right triangle. So remember, every triangle has three altitudes, right? So you start at a corner and you go to the opposite side at a 90-degree angle. So both the legs are altitudes. But I want the altitude that leaves the right angle, the altitude from the right angle. So I leave the right angle and I hit the opposite side at a right angle. So that's an altitude, right? It's the height of the triangle if I turn to the triangle this way, right? It's the height of the triangle from the right angle. So I'm looking at that one. That is the altitude I need. I don't want to use either one of these two altitudes. Okay? So the altitude inside the right triangle, the altitude is the geometric mean. So that's the one that's going to go in the two places. That's the one that's going to repeat. So my altitude is going to go in the bottom of the first fraction and in the top of the second fraction. Okay? What goes in the other two spots? It says it's the geometric mean of the divided parts of the hypotenuse. So when I look at the hypotenuse, I can see it's been divided into this part 8 and this part 25. So I can think of this as like part A, and this is part B. So it's going to be part A and part B. And this is kind of like my formula. There's not an official formula, but if there was, it would look something like that. Okay? So if I want to find Z, the altitude inside the triangle, I'm going to set up my proportion. My altitude goes in the positive diagonal, so my altitude is Z. And then the two parts of the hypotenuse go in the other two spots. And it doesn't matter which one you put where, but my two parts are 8 and 25. I could do 25 and 8, because when I cross multiply, it doesn't matter if I do 8 times 25 or 25 times 8. I get the exact same answer when I multiply 8 times 25. Okay, so I'm going to cross multiply, and I'm going to get Z times Z, which is Z squared, equals 8 times 25. Good, 200. And then I need to unsquare, so I'm going to square root, because anytime I see a square and a square root together, they cancel each other out, so I just have Z. 200 is not a perfect square, so I'm going to use my calculator to square root it. Does anybody need to know how to square root in the calculator? Do we know how? You have to hit Control and then the X squared button. And we're always going to round to 3 places. So Z equals 14.142, and after the 2 is a 1, so we're going to leave it a 2. I don't know what my units are here. I'm just going to say units. Okay? And technically, when you square root, you should get a negative answer also, but because the altitude is a length, we can't use the negative 14.142. We can only use the positive. Okay? All right, the next one we're going to look at is called the right triangle leg theorem. So we have the altitude theorem and we have the leg theorem. The leg theorem says the leg of the right triangle is the geometric mean of the hypotenuse and the adjacent part of the hypotenuse when it's intersected by the altitude drawn from the right angle. Okay, so we're still working with the altitude drawn from the right angle, so you still have to have this altitude. In both of them, you have to have the inside altitude. Okay, but this time the leg is the geometric mean. So that means this time the leg is going to be the one that repeats. Okay? What two things is it the geometric mean of? It's the geometric mean of the hypotenuse and the adjacent part of the hypotenuse. I'm just going to put ADJ for adjacent. Okay? So it says for my example to find both x and y. We're going to do one at a time. Both x and y are both legs of the triangle, right? You have a leg, and a hypotenuse. Okay? So let's say I'm going to start by finding x, this leg. X is a leg. Okay? So that means it's going to go in the bottom and the top of my portion. And then I need the whole hypotenuse in one of the leftover spaces. How far is the whole hypotenuse here? 33, right? Because you just take the two parts. Segment addition postulate says it's 33 units long. So that's what goes in one. And then the adjacent part of the hypotenuse. Do we know what it means by adjacent? What does the word adjacent mean? Yeah, next to. Miss Barner teaches in the room adjacent to me. Mr. Moore teaches in the room adjacent to me. I am standing adjacent to my cart. Whoever you're sitting next to, you're sitting adjacent to that person, right? So it's the one right next to it. So when I look at these two parts, 8 and 25, which one is next to this leg? The 8. And it's really easy if you highlight them, or if you color them, to see which one is adjacent. It's going to be the one that touches it. That's the one that's adjacent. It's like they're holding hands because they're best friends. Okay? So the 8 is the other part, is the adjacent part. And then this, I'm just going to cross multiply. So I'm going to do x times x, x squared, and 8 times 33, 264. How do I unsquare? Square root. My square and my square root cancel, leaving me with just x equals the square root of 264 is 16.24. After that is an 8, and after the 8 is a 1. So I don't round up, I leave it an 8. I still have another leg. I have to find the other leg, right? Because we have two legs. We want to know how long both of them are. Okay? So now I'm going to go find the other leg. The other leg, y. I'm going to highlight here, y. This is the other leg. So I'm going to put it here. Leg is y. Leg is y. How long is the whole hypotenuse? 33. It's still 33. That hasn't changed. What's the adjacent part this time if I'm looking at the leg y?
25.
This time it's 25. So when I cross multiply, I'm going to get y times y, which is y squared. And 33 times 25 is 825. Unsquare it by square rooting. And I end up with y equals the square root of 825 is 28.72. After the 2 is another 2, and then after that 2 is an 8, which means we have to round it up to a 3 to do correct rounding. So anytime you're doing these problems, you have to make sure you have an altitude coming from the right angle. So from right angle to right angle. And then you have to determine, am I using the altitude theorem or the leg theorem? Okay? All right. Those are going to be good little formulas when you get your note card to put on your note card, just FYI. All right. Practice, find the geometric mean between each pair of numbers. Find the geometric mean between each pair of numbers. So remember, your geometric mean is the one that repeats. So find the geometric mean. I'm going to use a G for geometric mean. You can use whatever letter you like. Between 6 and 9. So when I cross multiply, I'm going to get G squared equals 6 times 9. To unsquare, what do? Square root. So G is going to be the square root of 54, which is 7.348 what? 4, so we don't have to round up. Leave it as 8. If you don't feel like rounding or you don't know how to round, you can always write every single number that your calculator gives you, and you'll be correct because they let you round to more places, but if they say 3 places, you need to go to at least 3 places. Okay. All right. Number 2, find the geometric mean between 1/2 and 2. Geometric mean between 1/2 and 2. So G times G is G squared. Half times 2, 1/2 of 2 is 1. How do I unsquare? Square root. What's the square root of 1? 1. If you look around the room, you might find lists of perfect squares on the board because my college algebra class has been making themselves posters so they don't have to memorize their formulas, because I told them I wouldn't take the posters down when they took the test, but I also wasn't allowed to give them the formulas. So this is their way around that. They're decorating my room with the formulas. So, smart of them. All right, find the value of the variables in each triangle. So when I look at this, I have to decide, am I working with the altitude theorem or the leg theorem? What am I working with here? Leg. So I want to use the leg theorem, which says the leg is the geometric mean between the hypotenuse and the adjacent part of the hypotenuse. So when I fill this in, my hypotenuse is how long? How long is my hypotenuse? 6. How long is my leg? Not my leg. I don't know how long my leg is. I've never measured just my leg. How long is the leg? X? We don't know. Trying to find it. How long is the adjacent part? 2. Cross multiply to solve. So x times x is x squared equals 6 times 2 is 12. How do I unsquare? Square root. Squares and square roots always cancel. X equals the square root of 12. Oops, my calculator turned itself off. Which is 3.46. After the 4/6 is a 41, so just 4. Because the 1 says we don't have to round that up. Alright, the next one. Altitude or leg theorem? Altitude theorem. So that says the altitude is the geometric mean between part A and part B of the hypotenuse. So my altitude is y. So y is the geometric mean between, what are my two parts? 2 and 4. How'd you get 4? Yeah. It's like the corollary to the segment addition postulate, right? If you know the whole thing and you've used 2, there's 4 left for this piece. You just subtract. So 2 and 4. Y times y is y squared. 2 times 4 is 8. Unsquare by square rooting. The square root of y squared is just y equals the square root of 8 is 2.82. After the 2 is an 84, so I'm just going to put an 8. Because 4 says we don't have to round it up. 2.28. Okay. One more right here in this little row. Can't see the tip of it, but that's okay. We can figure it out. It's the same picture as the last one, only instead of y, we're finding z. All 3 of these are actually the same picture. So once we're done, we'll know all the segments in this triangle. Okay? All right, so on this one, am I doing altitude theorem or leg theorem? Leg theorem. So my hypotenuse over the leg over the adjacent part. The hypotenuse is how long? 6. Over the leg, that's what I'm trying to find, z, equals the leg, z. Over how long is the adjacent part? 4. Cross multiply. Z times z is z squared. 6 times 4 is 24. How do I unsquare? Square root. So z equals 1.8981. 898989. It repeats. So, did you say 3?
No.
4.
4.89.
And then what's after the 8?
8.
So we round it up to a 9. So 4.89, and then after that there's another 89, so the 9 says around the 8 up. Alright. Next. Now we get some fun ones. Altitude theorem or leg theorem? Those were my choices. My choices are altitude or leg theorem. I'm trying to find a leg.
You need to find the other part.
So do I care about either of the legs? Have I given the legs, and do I need to find the legs? Do I know anything about the legs, and do I care anything about the legs? I don't know how long either leg is. I'm not trying to find how long either leg is. But I do know how long the altitude is. So this is going to be the altitude theorem. Altitude equals altitude. And then remember that goes with part A and part B. So, when I fill this in, my altitude is 12. And my parts are 1 to 8. How do I describe this part? When you were up here, how did you figure out this was 4? What did you do? You did 6 minus 2. So if I know the hypotenuse, I take away the part that I know. not 2. It's the hypotenuse minus the other part, 8. Does that make sense? Okay. When you cross multiply, it's important to remember that you have to cross multiply to that whole thing, x minus 8, right? So when I cross multiply, I'm going to get x times 8 and 8 times negative 8 equals the other side, 12 times 12, 144. Did I lose anybody there? We're all okay? All right. What do I do first? Addition property of equality? I mean, you could subtract a negative 64 if you really wanted to do subtraction property of equality. But if you subtract a negative, you're adding. So 8x equals 144 plus 164 is 208. Then what do? Divide. Division property of equality. And I get x equals 208 divided by 8 is, oh, a nice whole number. We don't even have to round. 26 is 208 divided by 8. Question? Okay. You could on this one, if you didn't want to have to deal with x minus 8, you could just pick a random variable to put there. I could have put a y there. And I could have done 12 times 12, 8 times y, and gotten 8y equals 144. And then I'd have done 144 divided by 8 and gotten that this was 18. And then I'd have just added the 8 and the 18 together to get 26. So that's another method for doing that. Okay? To me, it just seems like more steps. So that's why I don't do it that way. All right. This is a fun one, too. Leg theorem or altitude theorem? Altitude theorem, right? We don't have the legs. We don't know. We're not trying to find the legs. We don't care about the legs. Okay? But we do know the altitude, and we have both parts of the, or we're looking for the parts of the hypotenuse. Okay? So this is going to be the altitude theorem again, which is part over altitude equals altitude over part. So my altitude is the square root of 21. My parts are x plus 4 and x. When I cross multiply, we have to remember that I have to multiply that x to the whole thing, x plus 4. So it's going to be x times x plus 4. And then on the other side, I'm going to have the square root of 21 times the square root of 21, which when you multiply something to itself, you're just squaring it, right? The geometric mean always ends up getting squared. What happens when you square and square root at the same time? It cancels out. So I don't even need a calculator to do this. My square root and my square root are going to cancel out, or my square and my square root are going to cancel out. And this is going to become x times x and x times 4 equals just 21. If you're not sure about that, you can always go to your calculator and you can do the square root of 21. Oops, I didn't hit square root. The square root of 21, you have to arrow out of the square root, times the square root of 21. You just get 20. Because when you square a square root, they cancel out. You just get 20. All right. Now, yesterday we talked about if you have an x squared in an equation and that's all you have, it's easy to solve. Or if you have an x in an equation and that's all you have, it's easy to solve. But when you have an x squared and an x, you have to factor, which means it has to be set equal to 0. So that's what I'm going to have to do here. I'm going to have to set this equal to 0. So I'm going to subtract 21 on both sides. Uh-oh. When I subtract 21, yesterday when we were subtracting by x, so we could just subtract from the like term. But here I don't have a like term. So I just have to put that minus 21 on the end. So I'm going to end up with x squared plus 4x minus 21 equals a 0. Okay, and then we're going to factor this. Do we want to use the x method?
Yes.
Okay. So for my x method, you're going to take a times c, and you're going to take b, and then you're going to put this over a and this over a. Okay? So a times c is 1 times negative 21, so that's negative 21. And b is a positive 4. And a is 1, so there's going to be a 1 under here, there's going to be a 1 under here. Okay? So now I need things that multiply to negative 21 and add to 4. So if I come off to the side and I do negative 21, my factors of 21 are just 1 times 21 and 3 times 7. Since I want a negative 21, I know something has to be negative and I'm going to be subtracting. Which am I going to subtract so that I get a positive 4? 3 and 7. Which one's the negative one? If I want a positive 4, the 3. So that negative 3 plus 7 gives me a positive 4, and negative 3 times 7 gives me my negative 21. So I put one number in the numerator here, and I put one number in the numerator there. If the numerators, or if those fractions reduce, we leave them as ratios, so they have to stay looking like a fraction. But if they reduce, we would want to reduce them. These don't, so I'm going to leave them as is. And I'm going to, the number on the numerator, or on the denominator, goes in front of x, so 1x. The number in the numerator goes to added or subtracted on the end, so minus 3. And then my other one, 7 over 1, so 1x plus 7 equals 0. And then your zero product rule says if you have things multiplied together that equal 0, at least one of those things has to be equal to 0. So x minus 3 equals 0, and or x plus 7 equals 0. Then you just solve each one. So when I solve this one, I add 3 to both sides. When I solve this one, I subtract 7 from both sides. So I end up with two answers, x equals 3 and x equals negative 7. If I was in an algebra class, Algebra 1, Algebraic Reasoning, Algebra 2, College Algebra, any of the algebras, those would be my answers. Those would be the x-intercepts of the graph, it would be the solutions to the equations, it would be the zeros or the roots. All four of those things are those answers. But in geometry, they may not both be the answer. I have to look back at the picture and see if they work. Okay? If I put a 3 in, and I say 3 plus 4, xw is 7 units long. That's fine. I can have a 7-unit segment. If I put a 3 here, wz is 3 units long. That's fine. So 3 works. If I put a negative 7 in, negative 7 plus 4 is a negative 3. Can I have a negative 3 units? No, you can't have a negative segment. So this one does not work. X has to equal the positive 3. Questions? Comments? Concerns? Alright, your assignment is in Schoology. Make sure you're staying caught up. You don't want to have to do all 5 of these lessons Tuesday night before your test on Wednesday.